Imagine a brave hero in a game. In Java, this hero is represented by an object, a powerful tool for modeling real-world entities. In this video, you'll explore the components of an object and gain an understanding of these concepts to help you create robust and well-organized programs. So, let's dive into the exciting world of objects in Java, using the Superhero project as your guide. But first, what is an object? An object holds the data or properties that define its characteristics and the methods that define its actions. Now, let's examine how this applies to your code. You've already defined a hero class as a blueprint for creating the hero objects. This class is like a template for all the heroes you will create. It defines the characteristics and the abilities that every hero will have. Now it's time to break down the components of an object. Every object has three components: identity, state, and behavior. Let's examine each component in more detail. First, there's identity. When you create a hero object using the hero class, it gets a unique identity in your computer's memory. Think of it like giving each hero a distinct name tag and an address. Remember, in your code, you created hero objects, Fire Fist, and Frost Blizzard. Although they belong to the same class, they are separate objects with unique places in the memory. Do you want to verify this? Try printing the values of Fire Fist and Frost Blizzard. Type println, double quote, Fire Fist, plus Fire Fist, one more print, double quote, Frost Blizzard plus Frost Blizzard, and run the program. Notice the last two lines of output. When you print a variable, you get its value as output, and the same thing happens here. Fire Fist and Frost Blizzard are reference variables that store the reference to the object as a value, meaning their identity in the memory. Java represents an object's reference as an alphanumeric value. Therefore, here at 6E8CF4C6 indicates that this object belongs to the hero class and stays at address 6E8CF4C6 inside the memory. You'll notice that both values are different, which proves that both objects have a unique identity. The next component is the state. An object's state represents the current value of its properties. These are like the hero's unique traits. Your hero class has member variables such as name, strength, and health. These store the state of each hero object. When you create them, you initialize them with specific values. Therefore, as soon as you create a hero object, its state is initially defined by these values. You can customize these values for different heroes as you did in your main method after creating the objects Fire Fist and Frost Blizzard. You modify the name of Fire Fist using the dot operator with the reference variable. Similarly, you altered the name and strength property of the Frost Blizzard. So, the state of one object can differ from that of another, even though they belong to the same class. The final component is behavior. This refers to the actions an object can perform. These actions operate on the object's state or data to achieve something. For example, the hero class represents a hero character in your application. The methods calculate punch damage and calculate special attack damage represent the behavior of this hero character. These methods don't exist in isolation. They use the hero state, in this case its strength, to calculate the damage caused by the hero's punch or special attack. You'll notice that both methods calculate the damage caused by a hero's punch by multiplying its strength by a number. This means the behavior of causing the damage is dependent on the hero's state of strength. Therefore, if the strength is high, the damage caused will also be higher, and vice versa. In this video, you learn that each object has a unique identity in memory. For Java, this identity consists of the class name, followed by an @ symbol and an alphanumeric value. This can also be called a reference of an object. You also explored how the state of an object is represented by the values of its properties stored inside the class's member variables. The dot operator enables you to customize these values for each object. Finally, you learned that an object's behavior is defined by its methods, which use its state to perform some action. Understanding these concepts will help you create robust and well-organized Java programs. Remember, objects are the building blocks of object-oriented programming, and mastering these concepts will make you a more superpowered Java hero.